Alright, here we go. It's been a while. I haven't done any streams in a while. I've been busy. I got a kid now. Not much else I can say about that, but today I'm doing a favor for my neighbor. This is actually the second one that I've done. It's a Honda ABS module, and we're going to dive right into it. I don't have a lot of time tonight, so here we go. I already cut the top off. Right here there's like a seam for this little cap, and I use just a oscillating tool with a metal cutting blade and just kind of slowly cut around the edge. It's the best way I've found to do it, otherwise it just takes too long. I tried using a hot knife and I got tired of waiting for that, and my hot knife just isn't powerful enough. You really need like a 50 watt, but this is just as good, just as fast, probably faster. And we're inside the module. So these units are problematic, and it's because of these little wires that are in here. 90% of the time. I can't say that that's always the cause, but it's typically what the cause is. So these are bond wires, and the bond wires go from the pad on the board to, you know, whatever else it's trying to connect. And let's see if I can get rid of that glare there. Alright. So typically what happens is these, from vibrations in the car or whatnot, these will break. They're aluminum. They're really small gauge, probably 24, 26 gauge. And what happens is they break, and then you lose connection to, you know, whatever part of the circuit that is, and the module stops working. So I'm going to see if I can find any that are broken. I'm just kind of pulling on them with a pair of tweezers. And I'm pretty sure we'll find a broken one because this module isn't working. I'm going to replace all the wires anyways. It's just how I do it. If you just repair the broken wires, they're going to eventually break again. So it's not really worth wasting the time to open it up and just fix, you know, one or two broken wires in there. You got to fix them all. So far, so good. These were crushed from cutting it. They got knocked over. Some of them have more than one going to it. This one has 3. All the wide tabs have more than one. Those generally are not the issue. Because if you have one still connected, it should still function. I'm not even going to check the triple ones. I'm just going to check the singles. So there's a broken one right here. This one on the end. There's 2, 3, 4, 5. And these were not damaged from the cutting, because they still had their nice arch to them. 6, 7, 8, 9. That one's good. That one's good. These ones the saw did touch, but it didn't cut through them. Good. Good. That one's good. This one still good. So just on this side alone, there's nine of these tiny little wires that were either extremely loose or broken off the pads. Let's try this side here. Good. Good. And I'm just checking them just because I want to see what's actually broken on it. Yeah. So those are all good. So if you wanted to do it the cheap and dirty way, you would just replace these that are broken. To me, that's half-assing the job, and I just wouldn't do it that way. This is a nice one because the tabs that are missing are not there. So you don't really have to pay too much attention to what wires are connected and how they're connected. So I'm going to go ahead and start removing these, and I use a razor blade to move, X-Acto knife. And I just start on the circuit board and just kind of shave them off. You want to be careful, you don't want to like damage the trace on the board, but you do want to get as much of the aluminum off as you can, because solder does not stick to aluminum. And there's some kind of goop on here. It's like a liquid silicone type stuff. I don't know exactly what it is, but I'm sure it's there to help with corrosion. You might break some off in little pieces, but you got to make sure you get all these out. Now the pads that are on the edges there, you don't really have to be too crazy with cleaning those off, because we're going to solder a wire to the whole pad, so it's just really on the board that we have to make sure we're getting them off. And again, you know, you got to have a light touch. You can't go in here and you know, dig with the X-Acto knife, because you're going to damage the board. Now, you do have a second chance if you do that. All these dots that are on the top are also connected to the same pads, but you're better off just going to the pads versus trying to jump wires to other spots on the board. But if you screw one up, you do get a little bit of redemption. This silicone stuff, or whatever this is incredibly sticky. So you want to make sure that, you know, any metal shavings or chips or whatnot are pulled off as you're going through. And I'm going to do one side at a time. This side is the hardest because it has the smallest pitch on these pins going to the connector over here. It's kind of time consuming, but I guess these modules are pretty expensive, and to me it's worth fixing it versus spending $1,000 on a module, or buying an aftermarket module or a used module. You can buy them, you know, buy these used on eBay, but guess what? You know, they're, unless they've been serviced, they're going to have the same problem that the original had. So eventually it's going to go bad anyway. So you might as well just pay to have somebody redo it. I don't know if there's enough interest. I might offer a service to repair these. It's not easy, so it won't be cheap, but I'm considering offering a repair service for these. You can see these little wires sticking everywhere, stuck to my hand. I keep a towel nearby. Let me zoom out a little bit. So yeah, first step is just to kind of clean off the pads, get any of the gunk off, any little bits of plastic that are left from cutting. You don't want any portion of the wires left in there if you can help it. And the little bits of stuff that you scrape off the pads, make sure you get them out, because you don't want to short out the electronics. So alright, that side's pretty good. So now next step is cleanup, and cleanup is crucial to this. You got to make sure that you do an adequate job cleaning this up. So this is just alcohol and a cotton swab. This silicone or dielectric grease, it's not grease because it's sticky. It's something else, but it doesn't like alcohol. Alcohol kind of breaks it down a little bit. I see some spots on the pads here where there's some wires left, so I'll scrape that off. Alright. But we want to get all this goop out of there, and when it mixes with alcohol, it kind of turns into like a little slime ball. So you can be a little aggressive with the Q-tip here. You're not going to hurt anything, but you want to get all that stuff out of the way so you can solder it, and you can kind of see it there. It's like a blob of this sticky crap. We're not going to, do more than we need to. I'm just going to clean the pads and the dots. And I'm just kind of using the Q-tip like a scraper almost, just to kind of scrape this jelly off these pads. And you want to get like kind of in this edge of the board there. Anywhere where we're going to be working, you just want to get this crap out of the way. So you're going to go through a fair amount of Q-tips doing this. Wrecks your tweezers too. But a little bit of fire can fix that, so I'll usually take the tweezers and hit them with the blowtorch after I do this, just to get any of that residue off. Otherwise everything they touch gets stuck to them. Little pieces of plastic, if they fall down onto the board, that's not going to be, a total deal breaker, but you want to make sure that any of the goop is out of there, because the goop is going to contaminate your solder joints. So these must be clean. When the board gets good and clean, you'll kind of get like you'll get like a squeaky sound on it. And the alcohol evaporates pretty fast, so. And any that's left will burn off when you're going through the solder process. Alright, so this side's pretty clean. Take another Q-tip. I'm going to have to reload on Q-tips. Go up and steal them from the wife. I'm just kind of helping it dry. Alright. And then throw this away because it'll stick to everything and it'll make a mess. Get a fresh paper towel for each one. Alright. Should be a little bit faster this time, since I've already done this once. And I must say that I did have success on it. It worked very well. I have this this is old wire. This is my grandpa's wire. I don't know where the hell he got it from, but it's got a cloth jacket on it. It's like wrapped with thread. But it's just solid copper wire, pretty thin gauge, and it's real easy to strip. I can just pull this wrap right off of it, so I favor using this wire. You can use Ethernet cable wire, but you have to strip it. So I just like using this. And you can see that the wires are going to go over each pad, and I'll do some of these and then zoom in. You do need, a pretty good soldering iron. You might be able to do it with one of them pine sill irons that are like USB-C that seem to be really popular. I'm using a 75 watt Hakko iron, Hakko. You will make solder bridges. They are hard to clear. I mean, you can use wick, but it's best to have a solder sucker when you're doing it. The tip that I am using is like a hoof type, somewhat small, but you need something to get some heat on because these are nickel-plated steel. So you got to get some heat into them for the solder to stick to the nickel. I'm using leaded solder. This is an automobile. It's a vibration environment. Leaded solder is just going to hold up better. I pretty much use leaded solder for everything. I don't think I ever really use lead-free. I don't even know if I have lead-free anymore. But we'll let the iron heat up, and then what we're going to do is we're going to tin everything on this side. You also need good flux. So this is Amtech. I just put it in a little dispenser syringe. It seems to work pretty good. Alright, iron's hot. And be liberal with the flux, because we're going to clean it and then we're going to pot these when we're done. So I'm going to do the nickel plated side first. You don't have to have the pads down to the gold. You just want them to be as smooth as possible so you get the best adhesion as possible. You're probably going to get my head in here just because I kind of got to get in here and look. I'll do my best to avoid that. You just heat up the pad, dance the iron on it, and make sure you got it tinned. You don't want a huge glob on there, but you want enough to where you could seat the wire in it. Big ones you gotta put a little more into. Now these are just sitting on ABS plastic, so you can't keep the iron on for too long, because if you do, you're going to start melting the contact into the plastic, and then you're just going to make a mess. So you do need to have a little bit of skill or a little finesse. The flux really helps keeping these from bridging. The big ones are going to take a little more heat, so just kind of help it out a little bit. Moving the iron while it's in contact with the nickel also helps the solder stick. So that side of contacts is done. Next, actually I'm not going to do the pads, and I'll tell you why. I want to put the wires in on this side first, cut them, flux it, and then I'll just go through and do all the pads after. We try something a little different this time. But now we're just down to putting the wires on. I'd say a fair price for repair work like this. I mean, we're talking a $1,000 module. I'd figure probably $100 an hour, 4 hours worth of work. And then, obviously some kind of warranty with it. Warranty would be against defective workmanship, not the module. I can't help if the module fails after I fixed it. I gotta get a pair of pliers. Alright. So now that we have our one side prepped, we're going to start fixing our wires on there. Again, we want to hit it with some fresh flux. I'm not cleaning in between. I didn't have the iron on there hot enough to burn the flux. If a little flux runs down inside there, it's not going to cause any problems. Just clean it as best you can. And this is not a highly active flux, so put a little bit of solder on the iron, and then we got to carefully line up each wire to each pad and solder them down. Now I get it tacked in place, and then I run the whole wire. And yeah, you will burn yourself. There's no way around that. One thing you can do, which I sometimes do, is you can take a Q-tip, cut the end off, and kind of use that as like a little holder to just hold your wire in place. Solder it in. Now you do have a little bit of flexibility if your wire moves on you. You just got to try and contain it as much as you can. I'm still going to use the X-Acto, the flat edge of the blade, line it up with the edge of the pad, and gently cut. You don't want the wire sticking over the pad. The hardest part about this really is making sure all the wires are lined up and set to the right depth. So I do use some force with the iron, and I make sure that I push that copper wire down into the pad. You want to make sure that you don't have a big blob of solder under there holding it down. You want to actually make sure that the wire is touching the pad and the solder is just wicking between them. So you can push on them a little bit, make sure they're seated. You can put a little bend in there too if you want. And this side it's not too bad, you just got to make sure that you don't short out. I'm going to redo this first one and push it down in there a little more. And I'll go through after and I'll hit them all again just to make sure they're soldered in there real good. I'm wiggling the wire to cut it versus stabbing the knife down through there, just because I don't want to damage the board. And the wires do want to raise off the pins, so if you're having trouble with that, you can try to put a little bend in the wire to try and keep them centered on the pins. You'll actually feel the wire drop down too when it hits that pad. Now the ones that have multi things on it, I don't know what gauge wire this is, but it's a lot more robust than that aluminum, so I just used 2 where it had 3. That's perfectly acceptable. If you're not heating up the wire, don't leave the iron on there. Put a little bit of fresh solder on the tip and use that solder to help conduct the heat. And again, I'll zoom in after I get all these on there. Got a lot to go. Granted, I have done this once, so I'm probably going to be a lot faster than you will. And I have a lot of wire, so I don't really care if I waste some of it. Good set of dental picks really helps too. So what I do for the the pads that have multi-tabs is I just use 2 and a little loop. The loop goes on the nickel plated side, and the free ends I put on the pads. You can feel the wires sink down. If they're not straight, put a little heat in there, straighten it out. If your piece of wire is bent, throw it out and get another one. Don't try to attach a bent piece of wire. You'll do more harm than good doing it that way. And some of these wires, they're not perfectly lined up, so you do kind of got to bend them a little bit and wiggle them around to make sure they're hitting the pad in the right spot. It really helps to have fingernails, so you can kind of push down on the wires and make sure that they're seated in there. If you're running low on flux, put a little more flux on there. I don't know if you can hold, you might be able to hold them down with the dental tool. This one has like little grooves in it. I don't know if this will help or not. No, that actually does seem to work quite nice. All about having the right tools for the job. Alright. Get some fresh wire. Keep going. I don't know if I'll be able to hold these with this while I'm trying to solder them or not. This might be after it's already fixed on there. And the wires do tend to want to dance on you a little bit, so you do have to kind of walk them to make sure they're into their right spot. And that little slight curve that I'm adding to the tip really helps get those wires exactly where I want them. And these are on there. I mean, I can drag the whole module around with it. I'm not going to go crazy and stress them out, but it'll be a hell of a lot better than those bond wires. Bond wires are good, but in an application like this, they need to be potted in something. So there's no mechanical connection with them. They're purely just making the electrical connection. So this one has a little jog to it. So we need to kind of bend it and then hook it around. Another great reason to have a dental pick, because you can really get in there and use it to manipulate the wires. Now these wires do go to the actuating coils on the other side, so we're going to test them, but when you test them, you will sometimes see shorts when you're testing them, but we're really looking for just connection between the pads. So if there is a short, that one walked on me. Add a little flux. And luckily this is like a glass embedded ABS, so it can take a little more heat than normal ABS. Alright, this one needs a little jog too. We just want to make sure that it's not going to touch the other wire. And I'll zoom in on this so you can see it. This one's easier than the other one that I did. The other one, all the pads were filled, so you had to take a picture of it and look at that beforehand to see which ones went where. Without these extra nickel-plated steel strips like in these blank areas here, it makes it a lot easier to understand where they come from and where they go. Keep the tip of your iron clean too, that makes a big difference. The little loops, they don't really need to be any specific shape. They don't have to be flat or straight or anything like that. I just do it so I can see that both connections are good. These big pads too, it also helps if you get a little preheat on them, just because they do take a lot out of the iron to get them juiced up. And these are stainless steel, so the solder won't stick to them. Alright. Almost halfway done with side one. Well, you have to use solid wire for this too. Stranded wire will not work. I mean, I guess I shouldn't say that. Stranded wire would work, but it's a lot easier to do with solid wire. The stranded wire, when you smush it down, it's going to want to fray and cause shorts and unnecessary frustrations. This should offer a far superior connection than the factory one did too, because it was basically like a little spot weld that was holding it in place. This is an actual connection going down the entire pad. I'm pretty picky about the connections. If the wire's not directly in the center of the pad, I move it. I want the wires to be centered. Again, this is the second easiest side. This side over here is the easiest. This is the hard side. This is the side over here that will probably give everybody the most trouble, myself included. Even with these wires being solid, they're still not super easy to make them stay in place. Alright, so now we have one side connected. Now we got to go through and attach them to the board. Good amount of flux, and I'm going to work the opposite way. These you do kind of got to put a little bit of force on. And what you want is a little ball on the end of each one. On the big pads, you want the whole pad covered. So I'm pushing the iron right down. You can't leave the heat on too long, because if you do, you're going to heat up the solder too much on the other side, and it's not going to, or it's going to lift the wire. Some of these do require some heat input, and you know, if you need to check like I do on this one, I want to make sure it's on the pad. Just get under and give it a little pry. And I look at it with a magnifying glass when I'm done. But depending on, you know, how much aluminum was left on the pad, you know, you might not get a nice little bubble. Alright, I'm pretty happy with that. Now I'm going to go over each one of these again. Just with a little bit of solder. Some Q-tip fuzzies in there I got to get out. Just to smooth out any ridges or little points from lifting the iron. So I'm not going to be on there long. Just enough to make sure they're on the pad. Smooth them out. This is also the step where you risk bridging, but to me, you get a better joint when you go over it again. Would it work? Probably. But I'm doing this for a friend, so I want to make sure I'm doing a decent job. There, I just bridged that joint there. So if you get a bridge, tiny little bit of flux, then you got to go in there and pull it out with your iron. Alright, side one done. Let's clean it up. We'll zoom in and we'll take a look. This is just the first clean. I'm just going over with a Q-tip just to get any of the big globs of flux off. I'll go over it with a little brush until it's pretty much squeaky clean. I generally don't work on car stuff, but you know, I figured I could take a shot at it, see what I could do. I prefer to be working on speakers, but I've been pretty busy. This is an exception, and like I said, this is just because I was asked to do this as a favor. And I am rushing a little bit because I do have to work tomorrow and I want some chill time. I've worked on the house all day, I'm exhausted, and I want to relax. So the goal is to get it cleaned up to where, you know, the Q-tip isn't coming out filthy. These are still a little dirty, so I'm going to keep going. I can tell right now these are all good just by looking at it, but we will test anyways. Alright. Show and tell. So that's as close as I can get with my camera from the top. But you can see, you know, we went from square pad, which is hard to see. You can see it, I guess, better over here. Square pad and to the finger. And the reflections kind of make it look like there might be some bridges, but there's no bridges there. I don't know if I could magnifying glass it or not. We can try. This is too strong of a magnifying glass, but yeah, you can see there's no bridges there. Here's the little jog where they both had to kick over like one slot. I know it's kind of hard to see, but that's a double pad there. Looks good to me. I'll give it a visual. I'm happy with that. Alright. On to the easy side. So we're going to start by getting little bits of plastic out first from where I cut it open. And I seal these modules back up, but I glue them with E6000. I don't use any sort of like solvent cement to glue them because you might have to get back in here. You know, if something doesn't work or whatever, at least the E6000, I can just cut through that with a razor blade and then re-glue it with the E6000. You don't want to use RTV. I don't know what that is. That's weird. There's like a fiber in there. And it's stuck in the... Huh. Weird. Looked like a little shard of plastic, but might be like an eyelash from somebody at the factory. That's kind of weird. There's a bunch of these little... well, maybe they're from cutting it. I doubt it, though. It doesn't look like plastic. And why is it on the back side of the screw? And we'll clean all that out. We'll use the alcohol to make the glue rubbery. Turn my iron off so I don't burn the tip out. And now we start cutting. So it says 4 individual wires and 2 doubles. And again, we're not digging into the board. We're just setting it free. You don't want to clean the goop off before you remove the wires. And the reason why is that goop, if there's any little metal shavings, that goop helps contain it, and it like gets stuck in the goop. So it's like a little added security if you're doing some extra scraping. Alright, there's all the wires on that side. Same process, alcohol and clean. I do check these screws also and tighten them before I seal it back up. I don't really know if that has anything to do with anything, but the other module I opened up, they weren't loose, but they weren't tight. You can see that big ball of goop there. If it comes off in a blob like that, you can reuse the Q-tip to get it good and wet and go back in there. Oh, my allergies are killing me. If you catch me muting, I'm probably sneezing. Either that or blowing my nose, one of the two. Alright, we're starting to get the squeak on this side. And I am fairly aggressive with the Q-tip when I'm cleaning these, because that goop does get kind of stuck in the little nooks and crannies. So you got to make sure you get it out. Just taking the tip of the blade and digging whatever's out of this crack. Seems to be pretty heavy in there on this side. Again, I'm being gentle with this too. I'm just kind of using the point of the pick to just kind of catch the goop. And then once it's all balled up, then I'll just pick it out. Alright, this side's done. Let's throw away that paper towel. Let that flash dry for a minute. I'm going to grab a drink of water. Alright, back to putting our wires on. I think using like Cat 6 Ethernet cable would be better, just because I think it would be a little bit smaller of a gauge than whatever this copper is. So there's some components on here that we got to kind of navigate around. You do have to be careful too when you're cutting this open. I should have said that from the start. You know, you don't want to go in too deep with your saw blade, because if you do, you're going to damage these parts here. Now, these can be replaced. I wouldn't, you know, want to do it. If you damage the chip, the module's toast. Throw it out. There is no way to fix the chip. I'm just picking little bits of plastic off that were left in there. I need to zoom back out too. The plastic probably won't hurt anything, but still I would like the board to remain somewhat clean. Just little pieces of plastic that shouldn't hurt nothing. You know, if you're worried about it, take a Q-tip, clean it out. We're already in the module, so the potting compound really is serving no purpose anymore. But it shouldn't hurt anything, but you know, what the hell. Alright. Flux. You have to use a quality flux. Don't use Chinese crap flux. Get Amtech or Kester or something good. Don't buy flux on Amazon unless you know 100% that it's genuine. We're going to tin these up here. So we got 10 spots on here. One thing I don't like about these hoof tips is you can never tell when the hoof is actually facing down when you have solder on there. That's why I keep the pliers handy, so I can readjust it, so when I grab it and go in, the angle's right. Shame on Honda for allowing this to be an issue, because I think this is a pretty common issue. There should have been a recall. They should have used spring contacts here that contacted the bottom side of the board. Just take the nickel, bend it into a little loop, put the board on top, screw it down, done. Probably cost, you know, $1 more per brake module. They didn't want to lose those bonus profits. It's really stupid. Bond wires are good, but not for an application like this. And they should have used ribbons, not wires. Ribbons are better against vibration. There's more material, they carry more current. All around better. Just stab myself with a piece of solder. Alright. Let's get this side. Save the hard side for last. Regardless of what type of wire you use, it is going to get hot. So, again, you know, expect to burn yourself a few times when you're doing this. See, this one I don't really like the position of, so I'm going to lift it and redo it. I want it right in the center, or as close to center as I can. These look like they have little jogs to them as well. One of the benefits of pushing down on the wire when you're breaking it too is it helps keep the wire real close to the pad versus trying to get in there and cut it. That whole wire went skating on me. So if you're having issues with the wires not behaving, add a little more flux on there, add a little more solder. If you have a bum piece of wire, cut it and start over. I can tell that's down. I don't know how many different cars these were used on, but be interesting to see some statistics on these. This side appears to be a little bit higher up than the other. So the wires are going, instead of going over, down, and over, these are just kind of going, or up and down. That tiny little bit makes a difference because I don't need to seat the wires like I did on the other side. Just gotta make sure I get them in the right spot. I'll still check them, like this one looks like it's a little high. I don't know if it is or not. Yeah, that one was. The other problem is, though, too, is the more you heat these things, the more they want to move around on you. I know that's on there now. These big ones. Doesn't hurt to get them a little warm first. And since the pads are offset, we'll just bend the wires a little bit. That's fine. That ain't gonna hurt nothing. It's a big pad. There's a lot of area to work with. So if they have a little twist or zigzag to them, not going to hurt anything. You just want to make sure that the wire is centered on the pad. That is kind of important. You don't want any parts of the wire overhanging the pad. Whew, that got hot. I would say if you've never done any soldering, this would not be a job I would recommend to do. Save this for somebody that has some time on an iron. Too hot. We're going to go over all these again anyways, so they don't have to be perfect on the first shot. And this is the easy side. You will understand the frustration when it comes to the other one. Alright. Make sure the wires are all laying flat. Same thing like the other side. We're going to flex it and then drop a little ball on each side. And the ball just makes sure that we get both sides of the gold pad. And I do push down pretty good with the iron when I'm doing these, just because I want to make sure that I get the heat flowing. It's another reason why I like the hoof point tip. I'm going to flux these and give them all another go. The only reason I'm doing this is I want to make sure that these are good solid joints. Got a bridge there. Clean the bridge. Without flux, you will never be able to wick up a solder bridge. There's side 2 done. That one shows up a little better. Each wire has a nice little ball on it going to its pad. There's a solid connection to the big ones. Now the nightmare one starts. I mean, it's not that bad. It's just hard because I'm out of Q-tips. They're closer together. And you got components in the way when you're trying to clean up the pads. So it kind of makes you work at a funky angle. At least until you get past these tall components. Just be gentle on the board. You want to cut through the aluminum, not through the circuit board. If you do a little scratch on the board, fine. Like this one, I nicked the trace there, but it doesn't go to anything, so it's fine. But you don't want to cut through any of the traces. And we're going to pot this anyways, so. That one looked like the pad came up with it. That could have been a problem. Let's see. No, we just nicked the pad. These are so close together, it's hard to see. That one was really loose. Alright, now to the far side. So these kind of sit a little bit below. So you might have to take off a little bit of plastic with them to get them out and get them flush. Won't hurt nothing. You can see the wires don't go flying because the goop kind of holds them on there. So the most important part is making sure that you get the right wire to the right pad. If you don't do that, the module's not going to work. And you could probably damage it. Luckily on these ones, they're just straight across. There's no zigzags. But if you get stuck, you should be able to use a magnifying glass and see the old position of the spot weld. I gotta grab Q-tips. I will be back. Alright. Now we can clean up this side. I keep my alcohol in a film canister because it eventually gets contaminated. So by doing that, I can just rinse it out and just squirt a little bit more in there, and I'm not like ruining an entire bottle of alcohol. These little pill canisters work great for that. Kind of messed the swab up. pads have to be clean though. If they're not clean, you're going to get bad solder joints. So take your time doing the cleaning. And this stuff likes to like stick and hide in the corners. And stick to everything else. You'll get it all over your hands. And it doesn't like to come off. The alcohol makes it like really gummy, which is good because it makes it easier to clean, but it will make your work area a mess. Alright. Cleaned up. I didn't turn my iron off. Alright, the hard part. So since these are lined up directly across from one another, wherever there's a gold pad is where you got to get the solder on one of these. And you can see how close they are together. I mean, there's not even a millimeter between them. That's half a millimeter. We got a flux. Same process though. And you can be a little generous with the flux here too, but we're just going to try and focus on getting the correct pins. The flux, when it melts, it'll flow, so that's not too big of an issue. And this is another reason why I like using the hoof point on the iron for this. These big pins here are the power pins. You can see the nickel doesn't always like to take the solder. Sometimes you do gotta get them heated up. But for whatever reason, like the rubbing back and forth action helps. So these, I'm going to use the point of the hoof tip. And try not to get the solder on the other ones. It won't hurt anything if you do. If there's a group of them together, you can try to do one at a time, but you risk bridging like that. Add some new flux. Flux helps take away the bridges. So does clean, fresh solder. Steel is not a very good conductor of heat or electricity. So the plating on these is really where you get your conductivity from. But you got to put a decent amount of heat in to get them warm enough for the solder to even go on there. And there is a little bit of ABS sticking up between these. There's a little goop in there too. Do your best to clean it out when you melt it. Make sure your pads are evenly coated. If your pads don't have a nice even thing of solder on there, it's going to be a lot harder to get a wire to stick. Sometimes you can't help melting that, on this side anyways, you can't help melting that little bit of plastic there. You just got to kind of go with the flow. If you melt a little bit, you melt a little bit. Let's see, we're on the second one here. Almost done tinning them. Alright. Final set of wires. Save the hardest for last. Do the doubles first. There's only, I don't know, there's only about 12 wires here. So it's not terrible. But it's just how close they are together that makes it suck. I'm working around these chips too. That's kind of a pain in the ass. A little fresh solder on the tip. So since copper is better at carrying electricity and heat, you know, just using 2 of these, even on the power inputs, is still not going to be an issue. And again, this is much thicker than the aluminum wires. So there should be no problems at all with the functionality of this, just by using 2 copper wires. I'm using the tool on these just because I want to make sure the doubles are laying flat. No other reason. Doesn't really matter if they're not, but you don't really want to rely on the solder to make your connection. I mean, even though that's what it really does, you just end up with a better joint if you're actually touching the pad and you don't have a bunch of solder holding the wire down. And these do kind of like to lift and dance, so. Alright, now the fun starts. This first one is behind a diode, so it's really hard to get to. You gotta have a little bend in your wire. After that, it's not too bad. These absolutely have to be centered. If these aren't centered, you're going to end up with shorts or bridges, and you're going to ruin your module. So this is where you got to kind of take your time. The second one's a little hard to get to also. It's okay if, you know, these aren't fully pressed down at this point. We're going to go over it. Just get everything centered first, and then go back and clean it up. Again, you only have half a millimeter of space in between these, so you're really going to have a good eye and a steady hand. When I go over them again at the final pass after they're secured to the board, then I'll make sure that they're pushed onto the pads. Maintaining the spacing right now is more critical than that. And I've soldered some fine pitch stuff before, but this is definitely high on the list for some of the smallest work. I mean, obviously when you're soldering chip pins, they're pretty tiny, but with those, it doesn't really matter if you blob up a bunch of solder on them because you got to wick it off anyways. These, you can't really get too much heat in the board, so you kind of have to and these wires do like to jump around. I mean, I have a pretty steady hand, but these wires are all over the place when you're trying to hold them from, an inch away and melt solder at the same time. And we'll go over the test procedure for all these, how to check them and make sure they're good. That one bent a little bit. There we go. These ones you do really need to give a good inspection to, with the magnifying glass, just to make sure that there's not like a tiny little microscopic ball bridging the two pads, because I don't know where this connector goes. I'm not a Honda guy. But if it goes back to the ECU, you could, probably damage some other stuff in there. Or in the car. So you gotta take your time and you gotta be diligent about what you're doing. Again, I apologize for my head being in the camera, but I don't really have a way to get a good angle on this. I need to be able to see what I'm doing. I am cheating on these a little bit. I'm using the point of the hoof tip, sliding it on the tab to melt the solder, and then I'm jumping the wire over while it's still hot. That's helping me keep a good alignment on these. I didn't do that before. It seems to be helping now. Let's add a little flux on here. Sun seems neglected. I'm also using my pinky to kind of support my iron, just to make sure my hand is as steady as can be. That one jumped. Alright, now we gotta fix them all down. Those bridged. It's really hard not to bridge these. Equally as hard to clean the bridge. Some of them you won't get that nice ball. There's just nothing you could do. That one's fighting me. And it bridged again. So to get the bridge off, you have to have a clean iron. I keep picking up this stuff. And flux, and then you just gotta kind of go in there real quick and jab the ball out. Perch the other one now. Trying to make the joints nice, and I'm fucking them up. More flux. These pads are really small too, so you know, it is a little more difficult to get that nice little solder ball on there. And do the best you can. Bridge that one. Getting flux everywhere. Sometimes adding a little solder helps. Sometimes it hurts. In this case, it's hurting. You want to make sure the joints are secure, and you want to make sure you get enough solder on there. But you don't want, there we go. You don't want any of those two pins touching one another. Unless it's one of these big ones. Then it doesn't matter. Alright, they all look good. Now we gotta go back and go over these again. For the wires, I'm gonna just a little bit of solder, heat up the sides, and make sure that they are on. Getting really lucky on this side. came out better than I thought. I did not think I was going to have it this easy. This one right here concerns me a little bit, but I don't think it's touching. It's flux all over my hands. My hands are like a sticky mess. Alright, let's clean it up. Get the flux off. And then I'm going to go wash my hands and we'll test it. And the way we're going to test it is we're going to try and go from the edge of the pin to the circle contact on the board. That'll tell us 100% that we're making contact. I'm not going really hard with the cleaning. I'm letting the alcohol do the work. Alright, let's get one to dry. And I'm not done cleaning yet. I'm going to brush clean it before I pot it. This is just to get most of the residue off. Alright, I'm going to go wash my hands. I will be back in a moment. Alright, Hands are all clean, they're not sticky anymore. The only thing that takes that stuff off is Dawn. Gojo would probably do it too, but I don't have any of that down here, so. Alright, clean up and testing. Oh, we'll do a zoom in. Put my wire away. Alright, let's see how we did. It's hard to see. We're looking at, reflections, but I wish I had a better magnifying glass. But this is a really high-powered one. Looks a little close right there. I'm going to give it a eye inspection. It is a little bit off the pad. I gotta fix that one. Does not meet my standards. So what I'm going to do is just heat it up and see if I can just push it a little bit. It's not at risk of shorting, but I just didn't like the way it was sitting on that pad. I still don't like it. I might end up redoing this one, we'll see. Try one more time to get it straightened out. Nope, we're going to redo this one. I want the wire sitting on the pads. So I'm going to re-tin that. These little aluminum wires are just sticking all over my hand. That's what I get for reaching in the garbage can. This is the one that was hard to get because it was behind that diode. There we go. Sometimes you gotta do that. Not much else I could say. Didn't feel like it was sitting nice. Sure enough, it wasn't. That is better. Put my flux pen away. We gotta clean that up again. And then we can start testing. Let's give the whole thing another little wipe down. Paper towels fell off the desk and went all over the floor. We're gonna need some fresh paper towels anyways. Alright. So now we should be clean. Now we gotta test. You need a good meter and a good set of probes. Put the meter in beep mode. We're going to go all the way around the whole entire thing. So we're going to go from the metal pad to the dot. No beep means bad connection. Now if you have some melted plastic in there, you got to scrape it out of the way. And you're going to have melted plastic. There's no way around it. But if you can get from the metal to the pad, and there's no hesitation in the beep, you know you have a good connection. So that side is good. I'll go to the other side. Same thing. If you have any little fuzz in there from a Q-tip, scrape it out. Alright, that side's good. Still got to clean the flux off of that side. Let's do that really quick. I don't know why I forgot to do that. The connector is the hardest part, and the connector's testing good right now. We still have to do a short test. And then a final clean, and we gotta pot it. Alright, again from the metal to the dot. Sometimes it's hard to find the dot that they actually go to. And sometimes two of them will share a dot. So all four of these will beep together. And the reason that is because there's coils on the other side. And these coils that drive the solenoids, well, it's just a piece of wire wrapped around in there, so you know, it's going to go through the coil around into the other pad, but as long as you can get from the metal to the dot and you check all the wires that are connected together and then switch it around, so like I'll go from the first dot, check all four, second dot, you know, check them all. It's not an ideal test, but at least you're verifying somewhat that you have connection there. I mean, it's the best you can do. I'm not removing the coils. That would be crazy. And then a short test, so just kind of walk wherever you have two wires that are next to one another. Just check and make sure that, you know, they're not touching anywhere where they're not supposed to be. If you touch the same wire, it should beep. I'm not worried about these. They're far enough spaced. This is mainly where you got to check. Up here. For shorts. None of these should, except for the power ones, none of these should be connected together. So alright. It looks like all our connections are made. Nothing is shorted out. At least nothing appears to be shorted out. Now we do a final clean and then we pot. For a final clean, I just have this little brush that I use for everything. And get a decent amount of alcohol on it. And I'm just going to brush in between the contacts. Clean the brush, go again. All this is doing is it's trying to remove as much of the flux residue as possible. You're never going to get it all up, but you can dilute it enough to where it's not going to cause you problems. I don't want to wash this board or spray it with flux off. So manually is the better way to go. You want to do it until the whatever you're brushing off is clean. It doesn't have like any sort of brown tinge to it. And this is going to help our potting compound stick better. It's not really potting compound, it's E6000. It's one of my favorite glues to use for a lot of things, especially electronic stuff. It's just a damn good glue. Let's go over all the contacts several times. Best we can just to get the majority of the residue out. We're not really trying to adhere these down. What we're trying to do is make sure they don't move. Now, I mean, they're not anywhere near as delicate as those tiny little hair wires that were used in the factory. I really don't know why they did that. Like these should have been spring contacts. I think spring contacts would have been a much better way to go. Or even like card edge connectors where the board actually like slid onto them, but I don't know. I'm sure it was done this way for simplicity or cost. One of the two, but crappy design in my opinion. I do not have my screwdrivers readily available, so we're just gonna check these screws. Just make sure they're torqued down. You don't have to go hog wild. You don't want to strip them out or crush the board, but you want to make sure they're tight. Alright, now we dry and pot. I guess I'll go through that process too. It's hot air gun, 100C. We're just going to heat up the area that we cleaned just to flash off any of the alcohol that remains. You can use a blow dryer. You could just let it sit and wait and air dry. I just need to get this done tonight, so I will not be air drying. It's still a little tacky from the flux. There's really nothing you can do about that. You can clean it and clean it and clean it. I used a lot of flux in here. Alright. It's dry enough. You know, you don't want to get it too hot, but just hot enough to flash the alcohol off, and then E6000. You get this stuff a lot of different places. Comes in clear and black. Color doesn't matter. It's kind of like a rubberized I don't know, it's just like a rubber-based glue. I don't even know how to explain it. But it self-levels. And for this type of work, it is fantastic. You don't have to be fancy with it. You don't have to be pretty with it. Just cover the contacts. And don't get it all over the place. It dries to a really tough, rubbery type of glue. And that's it. This needs 24 hours to dry. Then after that's dry, I will use the same E6000 and glue the cover cap back on. I'll do one shot around the base of it, all the way around here, put the cover on. I'll let that set up and flash, and then I go along the outside, all along the perimeter, just to make sure it's good and sealed, so no moisture or anything will get in there. And that's it. That's what it takes to repair one of these Honda brake modules. So I hope I could help some people. I know this is not an easy repair, but there's some talented people out there that can, that have the tools that can solder. So, if you have a friend or a buddy, or I think there's even people that offer services to do this online, but this is the how-to on how I feel is the right way to do it. I don't feel that just tacking the broken aluminum wires back on is appropriate. I think this is a much better way. I think it's much more robust, and it'll far outlast the car, in my opinion. Like I said, I did one of these. It worked fine. All the lights went off on the dashboard, so hopefully this unit will be back in service and back to life. So thanks for watching. Like and subscribe. Hit up the comment section. I'll try to answer some questions if you have any questions. And until next time. I don't know when that'll be. Hopefully I can get back to doing some subwoofer work soon. I got a lot going on. I don't have the time right now, and I did this for a friend. So hope I helped you, and have a good one.